All right, it's starting and it is started.
Great. Good evening, everybody. Welcome to today's presentation. Quickly untangle and navigate complex semantic models. And as Kevin P. alluded to, this is how to unspaghetti your Power BI model. Right. Quick look through the agenda today. We're going to do a quick introduction for myself. We'll talk a little bit about why semantic models matter to what you do. We'll give a brief introduction to the Star Schema, and then we'll talk about the bus layout, which is this technique that helps us untangle the model. And you may have already seen a little bit of this on LinkedIn or on the advertising for this event, but that is the ultimate goal. We want to take the mess of spaghetti that you see on the left and turn it into something a little cleaner that you see on the right side. And then we'll do a live demo of how that happens, in addition to the explanation. And time permitting, we'll also do a detailed tour of what's in the model view of Power BI, because there's a lot of little hidden gems in there that make it a lot easier to use. All right, a little bit about myself. My name's Collin Tsui. I'm a professional engineer by training, and somewhere along the way, I realized that I was just swimming in data my whole career, and decided that data is actually a little more fun than engineering, so I made the switch. But of course, being a data nerd, I decided to illustrate my career in the form of a chart. Started at the University of Calgary, was at a Fortune 500 engineering procurement construction company for nearly 2 decades. And through that time, I spent so much time learning about Excel. And that really forms the basis of what I know about data is business first, business purpose and business value first. And we do what we needed to do to make it happen and get the value out of the data. But towards the end of my tenure at that Fortune 500, I discovered this tool called Power BI, and I just fell in love with it. And I realized how much more it could do. Things that used to take me, when I was managing finances on a project, things that used to take me weeks to do can now be fully automated in Power BI. Of course, I'm preaching to the choir a little bit here, but I saw the potential in that, and I pivoted hard into Power BI as a career move, and found some opportunities in different companies, both with a startup and with a Power BI consultant to really learn the ropes, and then struck out on my own to start my own company, and that's what I do now. Power BI, data analytics as a consultant, with a specific focus on the construction industry and adjacent companies like their suppliers, vendors, and contractors. All right, so why do semantic models matter? Why is it that, most people, when they start with Power BI, and I include myself in this camp, when I started playing with Power BI, I went straight to the DAX. That looked so much like what I was already doing in Excel, and it was something I understood immediately. But what I quickly found was the DAX got really, really complicated to the point where I didn't know what was going on anymore. And the more I dug into it, the more I realized that I was skipping a crucial step, which was setting up the model correctly. So the model forms the foundation of a Power BI report. It defines the data structure and the relationships between those data structures. The model encompasses the business meaning and the logic. In other words, you have the data, but a table of data in and of itself is not very valuable. It's how those tables, many tables of data, connect with each other, how they relate to each other, that really gives the overall data set meaning. And the semantic model is where all of that happens. And in the Power BI context, having a semantic model set up properly is also needed for security features like role-level security. I think most importantly for most developers that work in Power BI, the model matters because it determines the complexity of your DAX. A poorly laid out model makes the DAX incredibly complex, maybe even makes some analytics impossible to do. But having the right model, having the right relationships set up in the right way can make your DAX a lot simpler, or at least a lot more manageable. Even if you're doing some very complex analysis, that DAX can become much more manageable. On the user end, your semantic model, the way it's set up, the way the relationships are set up, can drastically affect the report load time. Even if something works, it might take a long time to work. And having a model set up properly means you can crunch millions of rows of data and still have it load in a very reasonable, maybe even snappy amount of time, something that's very appreciated by the user base. Another thing, and this is something that when I started out, it took me a while to understand, but having a data model set properly gives your Power BI file scalability. If you only have a few hundred rows of data, you can have some many-to-many relationships, and things will still work. It'll feel fine. But the moment you scale up to a few thousand rows or tens of thousands or hundreds of thousands of rows, that Power BI model that barely held together unravels really quickly with volume. And also maintainability over time. Having that model be clearly displayed, which is what we're really talking about, we're going to be talking about today. Having it displayed means that it makes it easier for you to remember what you were doing, and it makes it easier for someone else who wasn't necessarily there at the inception of the model to maintain it. And from another perspective, if you're asked to take over another model, some of the techniques that we're going to talk about today make a model that you may not be familiar with much easier to read and understand and then maintain and take over. And last but not least, having a great model bestows an air of mystique on the geniuses that can decode such complexity. I'm going to assume there's a whole lot of laughter going on and that everyone's just on mute and therefore I can't hear it. So with that, we'll move on. So one of the basic tenets of Power BI is you want to set your model up in what's known as a star schema. We're not going to go too deep into it today. It'll just be a quick review here, but let's start with why the star schema is important. A star schema enables better understanding, human understanding of the model. Your traditional transactional databases are set up with many tables in a lot of relationships between them. It is a real tangle of relationships. And a star schema is meant to what's known as denormalize the model or flatten the model to some extent to make it much easier for a human to read and understand it. And as we talked about on the last slide, having that star schema also enables better, simpler DAX. And lastly, the Power BI itself is optimized for a star schema model. So in other words, if you follow the star schema, things just work better, things work faster in Power BI. So what is this magical star schema? What makes a semantic model follow a star schema? There's a few basic characteristics that define what a star schema is. And we'll talk about the star schema in terms of one fact table at first, but know that this can also apply to a model containing many fact tables. Now, before I even talk about a fact table, we need to talk about what a fact table is. A fact table is, and the word fact is actually really deceptive for someone who's new to the data world, including myself when I went through that. A fact table, I think instead of the word fact, I think of the words events or transactions, things that cause multiple entities, peoples, things, time, to interact with each other. And you're recording down these events or transactions. That's what a fact table is. And around the tables that support a fact table are the things, the people, the places, the times, and the dates that need to go into a fact table. Those are what's called the dimension tables. So the star schema puts the fact table at the center, and around that fact table, you can have one or more dimension tables. And it's really important that within the context of a star schema, that's about as far as it goes. You have one fact table and one relationship hopping to a dimension table. And those dimension tables do not split into further relationships. Because if you do that, that goes into what's known as a snowflake schema, and that you start leaving that optimized function of Power BI. So we want to denormalize those multiple layers of dimensions and flatten them into single dimension tables. Another important feature of the star schema is that you have direct relationships only. You don't have relationships that go from fact tables to fact tables or dimension tables to dimension tables. So the direct relationships flow strictly from a fact table to a dimension table. And the cardinality between them, in other words, the way that the relationship works is always many to one. And you can tell the many because that's the star, and the one is the number one. I'll explain all that in the symbology in a little bit when we talk about the bus layout and how that works. But the idea is you always want that relationship flowing in a specific direction from the fact table to the dimension tables, and not the other way around and not in different configurations, because then you start leaving what we call the star schema. So that's the quick review of what a star schema table is. Oh, and no relationships between fact tables. If you have two fact tables, you do not relate them together. And if you have dimension tables, you do not relate them together. And that's what makes up a star schema. So you can have a star schema with one fact table in the middle. And as your model grows in complexity, you probably will need to add more fact tables. And your semantic model can get more complicated, as you can see here. We have multiple fact tables and still the dimension tables all around. A lot of the introduction to Power BI courses lay out the semantic models this way, with the one fact table in the middle and a few dimension tables around it. And as things get more complicated, they stack things on. And you can see the relationship lines start crossing over each other. It makes it a little harder to understand. Now, fortunately, Microsoft has put together a tool that automates the display of these tables that makes it really easy to understand. And it looks like this. So Microsoft, when they make something really easy, it may not always be optimized for human beings. So one of the things you can do in the model view in Power BI is what's called an auto layout. Unfortunately, the auto layout gives you this, which actually looks more like spaghetti and meatballs, not less. And what we'll talk about today is how to untangle that a little bit and make it easier to work with. A lot of people, when they see that auto layout, they immediately go back to the single fact table view. And within one model, they may create multiple tabs within that model view, each featuring a single fact table in all the dimensions that relate to it. And there is a little bit of automation within Power BI that makes that easy to do. But that also means now your data model, your semantic model, in order to really look at it, you need to flip through 3, 4, 5, a dozen or 24 tabs just to really understand what's in your data model. And it really makes it hard to see how the fact tables share common dimensions, or how many fact tables a specific dimension is supporting. And it makes it much harder to find where the important tables are in your model when it's spread out across multiple views. And it was in this struggle of trying to understand data models quickly that I started really trying to explore what are some better ways to do it. And one of the better ways that I stumbled across, it's what's called the waterfall layout. Rob Colley, who's one of the pioneers in the Power BI community, came up with this way to view the semantic model, which is you put all of the dimension tables on the top and you put all of the fact tables on the bottom. And in that way, using that as a standard way of operating, the folks on a team can very quickly look at each other's models and discern between facts and dimensions. Now, unfortunately, well, before I say unfortunately, it is a very good way to very quickly see a model. And trust me, I prefer this, 100 times more than the auto layout. There's no question that this is an improvement. But for me, when I was looking at the waterfall, it still left something to be desired. There is still that plate of spaghetti in the middle that made it really difficult to trace specific relationships. And so I started playing around with how the tables can be set up here, and eventually arrived at the bus layout. Now, what is the bus layout? And it's just a way of setting up, moving your tables in specific ways to make it much, much easier to see and understand the relationships between them. And when you do it that way, there's also some tricks that makes it much easier to ensure you're not just adhering to a star schema, but also some best practices that are typically associated with the star schema. So the bus layout will let you distinguish very quickly what's a fact table and what's a dimension table, let you see existing relationships, not just that there's lines between two tables, but very quickly verify the cardinality and the filter direction between those tables. It lets you check that you do have a star schema, and I'll talk about how we do that in just a little bit. And when you have the semantic model laid out this way, it's really easy to see anomalies or advanced structures such as bridge tables and whatnot within your semantic model. And lastly, confirm best practices. And we'll go through how to do all of this. So what is the bus layout? The bus layout is just a way of setting this up. And it's called the bus layout. And I see Donald's on the line. Donald's going to give a thumbs up on this, I know for a fact. The bus matrix is something that the Kimball group came up with many, many years ago in the pioneering days of databases. And basically, it was a way of indicating which dimension tables interact and support with which fact tables. And it was just a table with a matrix with X's on it to denote when there needs to be a relationship between a certain fact table and a certain dimension table. But that layout was very effective in communicating what would otherwise be a complex web of relationships. And what the bus layout is, the name implies it is a homage to the very elegant way of showing a lot of complexity within how to show what's in a data model. So we create the bus layout, and the bus layout also works really well because it takes advantage of some of the ways that Power BI auto routes the relationship, right? That auto routing is what creates the tangle of spaghetti lines between tables. And the bus layout takes advantage of that auto routing and uses some of its nuances to make a clean, effortless layout. So in order to create the bus layout, you need to first identify which tables are the dimension tables. And during a live demo, I'll talk about ways to help spot that really quickly. But you find all the dimension tables and you move them to the top. And the way Power BI is set up, I have a little bit of OCD, so I like things to line up really well, really perfectly. And it's really hard to do that in the model view because Power BI doesn't have a grid. It doesn't have a way for you to automatically line things up. But when you drag everything to the top, you hit the border of that view and everything automatically lines up. So that is a nice little bonus. It gives you that nice clean line across the top to know that you got everything there. So you move all the dimension tables to the top. And then the next thing you do is you take all the fact tables and you move them to the left. And again, there is an invisible edge on the left side that if you push your tables up against it, they stop moving further. So it gives you that nice clean line on the left. And that's it. If you do that, any existing dimensions or existing relationships, will get to this very clean looking L shape, right? One right angle to go between two tables, assuming your model is basic star schema. There will be some complexities. If you're taking over someone else's model, chances are you'll run into some complexities. And we'll come to that in just a little bit. And then lastly, you got your dimensions, you got your facts. You may also have some disconnected tables. Your measure table would be one of them. If you have any field parameters, that would be another example. You move all those off to the right and just push them off to the side for now. And we can sort out where they go sort out where they go afterwards. Because if they're not part of any relationships, they don't really need to figure into this first portion. And one thing that I like to do is collapse all the tables as well. So at the bottom of every, let's see here, let me find my mouse. At the bottom of every table is this expand and collapse option. I actually like to collapse every table. And what that does is actually just gives me a lot more real estate to work with because for a lot of tables that you have, there are sometimes very many columns. And usually when I'm working in the model, I'm not concerned with most of the columns in a table. I'm only concerned with the columns that are involved in a relationship. And there is a setting that you can change in Power BI. It doesn't come default, but you can change it to this setting where when you collapse the relationships, or sorry, collapse the table, only the columns that are in relationship remain. And I'll show you where to find that. Changing that setting and then collapsing all the tables makes it really easy to find the columns that matter when you're working on a semantic model. You can always expand it if you need to see the columns, but by default, I keep it collapsed. So we have all the dimensions on the top, all the facts on the left, and all the relationship lines down the center. What are some things now we can do to make sure that this is adhering to the best practices of a star schema? Well, first of all, you want to make sure that all of these lines are a single right angle between two tables. If you see there are some lines that go from a one dimension table to another, that's going to give you a flag that something's not as expected. If you see lines between two or more fact tables, that would give you an indication that something is not as expected. And we'll see that in the live demo so that you know what that looks like. But you want those nice, clean, single right angle lines to tell you you are set up in potentially the right star schema. The next thing you want to look for is the little box below all the tables in the top row that say 1 or star. You want all of those to say 1 because those are your dimension tables. So those are the ones you want to be on the one side of that relationship. And then the next part of that is you want to look down your fact tables on the left, and all of those should be on the many side of that relationship. So that's the bus layout gives you this very quick way to see, are all my dimensions on the one side of a relationship and all my facts on the many side. And then the one other thing you want to look for is all those arrows that are on those relationship lines. They should be either pointing down or pointing to the left. And that tells you that they have your filter directions are pointing in the right way. You're not going to get reverse filtering when you don't intend to. So that's it. Those three things get you very close to a star schema.
Can I ask one question to you?
Yeah, absolutely.
So on your line, your blue box going through the facts,
Yeah.
right? Making sure that the asterisk is down the left.
Mhm.
Sometimes some tables come out as a 1-to-1,
Yes.
right? And
Yes.
so, technically that doesn't totally void the star schema, but do you recommend changing them to 1-to-many anyways to meet this, what you're kind of saying there, the star down the left?
I would. That's model dependent, so that's not always going to be the right answer, but by default, that would be what I would do. It does. It's hard to think of too many instances where you have a fact table and you don't want it to be on the many side.
I agree with you. I just wanted to throw the question out.
Yeah.
And also say that people could raise their hands or put questions in the chat, and then we give Collin some feedback too.
Yeah, absolutely. We don't have to hold the questions till the end. Be happy to answer as we go. So that's it. We do these three things. Ones across the top, stars down the left side, and arrows pointed down and to the left. Down or to the left. If you got those three things, and you have your facts on top, facts or dimensions on top, facts on the left, that's it. You have a fully compliant star schema. Without all of the that's a much easier checklist to go through than it would otherwise be. That's the power of the bus layout, is being able to get to that star schema, see any deviations from the star schema, and confirm that you are in a star schema really, really quickly. There are also a few best practices that I found make this a little bit easier to use, and that is, as I said earlier, if you collapse all the tables, you're able to very quickly see which columns are in a relationship. For the dimensions, it usually means you only have one field, your key field, that's in relationships. There can be exceptions to that, but for the most part, you want your key field. Usually, in the traditional databases, that would be your GUID, right? Your universal ID, the string of numbers connected to each other. Power BI gives you a little more flexibility around that. But even then, if you're using a date field or a name field, you want to use that consistently between all of your fact tables, unless you have a very good reason not to. So typically what that means is once you collapse all your dimension tables, they're all going to be the same height because you only have one column showing as being in a relationship. So this is a very quick way to confirm that. And then the other is on the dimensions running, or sorry, on the fact tables running down the left side. Typically, what you want is all of these fields that are in the relationship, you want to hide them because you don't want the report developer to select the fields from the fact table. You would rather, the best practice is to use the related fields from the dimension table. So you want to hide them by default so that you don't accidentally pick the column or the column from the fact table. Instead, you want to make it easy and by default to pick the column from the dimension table.
Hey, Colin, we got
Yeah.
two questions that are pretty much related.
Yeah.
So if you have a model that has a lot of dimensions in it, say greater than 20, how do you handle that? Would you end up breaking it into multiple pages, like what was kind of discussed earlier, just have maybe more facts on those pages or something? What's your thoughts there?
Yeah, that's a great question. The easy answer is get a bigger screen, but a bigger screen just leads you to want an even bigger screen. I say that only slightly in jest. What I've done is sometimes if it's not too many more. So for example, in this example here, we have 5 fact tables, and that takes up pretty much the whole screen. You can zoom out a little bit and still reasonably squeeze in 1 or 2 more tables. But beyond that, if you need to scroll down a little bit, sometimes I find that still works. And if not, it doesn't, there's nothing that prevents you from starting a second page, also using the same bus layout, but grouping your related fact tables together, or not related, grouping fact tables of a similar theme together. So in this example, this is some construction paperwork. So I would say all the forms that are related to design would go on one page of the bus layout. All the forms that are related to construction would be on another page. All the forms that are related to quality would go on a different page. And another page for tests, for instance. So you can kind of group different fact tables together if you really do need to break beyond one screen. And related to that question, and this is something I haven't experimented with, but I got feedback from when I posted this idea on LinkedIn, is somebody said at 50 tables, everything works fine. If you have 51 tables, the auto routing starts to break down and it does some funny things. So I haven't experimented with that, but just a word of caution, you may run into that, and that may necessitate you break it out into multiple pages. And again, I would do that by grouping similar fact tables so that there's at least some logic to how you're doing it. And I think with all that, it is still down to personal preference. There is also nothing that says you can't just run all your fact tables down the left side and you need to scroll down a few screens worth. It makes it a little bit harder to work with dimension tables. Another solution that I've seen is actually instead of putting your dimensions right at the very top, I've seen a few users suggest putting the dimensions near the bottom of your screen, and then having more facts underneath that. So you would have facts on the left side, and then when you get to the end, the cutoff for that first screen before you need to scroll, you put all your dimensions, and then you can scroll down and put more facts. So it kind of lets you double up on how many facts you can squeeze in before you run out of real estate. That's another approach to it. But again, that may double your capacity, but eventually you will run out, and you need to decide how you want to handle that, whether you're comfortable with scrolling or whether you need to break it up. That's just the reality of working with a finite amount of screen real estate. All right. What else do we got? Miscellaneous. Okay, so far we've seen a really clean layout with perfect star schemas. But when you inherit a model, that's not always going to be the case. You may have users that either were doing something a little more advanced or something a little more beginnerish, and they didn't quite understand what they were doing, so they threw some tables together, related them, and made it work. Some common patterns you're going to see is, well, you're going to have some disconnected tables. We talked about that. these are tables that are not in any relationships. So that is going to be a flag for you to look for. Should these disconnected tables, should they be in a relationship? Because if they should and they're not, that's something that you can fix. Personally, the measure table, personally, I use a measure table, and I'm fully recognizing there's a lot of debate in the community about whether or not a measure table should even be used anymore. If you do want to have one, I like to keep it in the top left. Nothing says you have to keep it there, but I like it there. It just tells me that that's where it is. And then on the right side, I keep all my field parameter tables. And usually that's about all the disconnected tables I run into. If there's another table that's disconnected, I'm really asking serious questions about why it's disconnected at all. I like Kevin's comment. It's funny some advanced and beginner features look the same. That is so true. So that's disconnected tables. Another one that's common, this is more among the advanced crowd, is the beginner crowd would do a many-to-many relationship between two tables, but that can cause performance issues as your model gets bigger and bigger. So it is generally recommended best practice to steer well clear of many-to-many relationships, unless you really know what you're doing and you understand not just the performance implications, but also accuracy implications. It's recommended to stay well away from many-to-many, unless you really have a very good idea of how to work with it.
You ever use junction tables?
Junction tables? Not familiar with that name, but I typically use what are called bridge tables. It sounds like they might be similar things, just a different label on them. But a bridge table.
That's what I thought of it as. It's been a while since I've used the term. But
yeah.
I remember it being a meta table in between to kind of join the two.
That's exactly what it is. You have a table that shows the relationships between this, so that lets you get the effect of a many-to-many relationship, but only using many-to-ones. Now, this is not a modeling course, so I'm not going to get into how to do that and when to do that. SQL BI has an excellent modeling course that gets into a lot of depth on that, as do a lot of other educators and influencers. But if you do see a bridge table in between, between a fact and a dimension table, this is where you would see it. This is where you would put it in the bus layout. You would put it at where that relationship would typically bend at the 90 degrees. You put the bridge table there, and you can see in this case, it is a one-to-many from the dimension to the bridge, and then a many-to-one from the bridge to the fact table. And you can see the filter direction now is bidirectional. Again, not stars. This is not going to be basic star schema now. We're leaving that star schema territory into a more advanced layout. So that's why now we're saying that you have a one side of a relationship on a fact table and a bidirectional relationship. Make sure you know what you're doing before you do that, because it causes a lot of expected effects, but you have to know what to expect before you go there as a beginner. Snowflake. This is the beginner side of it. If you're not familiar with the star schema, it is tempting to use the tables exactly as they come out of the database, and the denormalized dimension linking to a dimension linking to a dimension tends to show up. And I have seen, not exaggerating, 9 levels of snowflaking in some databases. That can get a little bit messy. So I've only shown 2 levels here, but recognize that there can be a lot more. And if you see that, now you know what it is. And it is basically just a dimension table, the regular dimension table, but instead of the categories being listed on the dimension table, the categories are pulled out, what's called normalized, into its own table. And this may happen at multiple levels. So the classic example used in Power BI instruction is you have products, and then those products belong to subcategories, and those subcategories belong to categories, and those categories belong to business lines, and so on and so forth. So you can have multiple layers in separate tables. Best practice in Power BI is to denormalize that and flatten all those dimensions into one single dimension table. Beyond the scope of this course, how you do that, you typically want to do it in Fabric or in Power Query. But if you do see it, that's what it is. That's what it would look like. And this is how you would lay it out in the bus layout so that you know that's what it is. and can very quickly spot it. And I see KP here just jumped in. Junction, bridge, mapping, and link tables are all the same, just different names. Yeah, a rose by any other word would smell as sweet. And these bridge tables do give you some pretty sweet functionality. All right. So this is the bus layout now. This is the non-simple. This is the version with a few more, a little bit of spices added in, right? And to use the spaghetti metaphor, we now have some peppers and some herbs thrown in as well. We've got the bridge tables, we've got some snowflakes, and some disconnected tables as well. So that is the explanation. I'm going to pause here to see if there are any questions before we go to a live demo of how we actually go from the auto layout tangle into a cleaner bus layout. Yes, Aman?
So, Collin, you have all these different examples of, different how you treat the different. What about a cycle? What if you have a loop in your model there?
If you have a loop, that would not be Star Schema. So what the bus layout is intended. By the way, the bus layout doesn't fix the issues, right? The bus layout just highlights the issue, so you can quickly find what they are, where they are, and which tables are involved. You're still going to need to solve those problems before you get that simpler DAX and that faster performance, right? But all this does is going to bring this to your attention really quickly, rather than hunting and pecking for a long time before you realize that's what's causing the issues. So if you have a circular structure within your model, it's going to show up as lines that are not this simple right angle. And when you start dragging the tables around, you may see that the lines start crossing each other in ways that are really unexpected. And because you will leave that grid as soon as you do that, lines that leave that grid, they'll jump out at you, and you'll be able to find those really quickly. Did that answer your question?
I was just having fun. Thank you, Collin. I'm sorry.
Besides the potential error that you get until you make that relationship, one of them inactive.
Mm-hmm. Yeah, and by the way, that's a good point. I didn't really mention that, but if you have inactive relationships, the bus layout still does support that. And so in this example here, I have the calendar table, and 3 of these lines feed into this fact table. 1 of them is active and 2 of them are inactive. So that is perfectly fine. It works perfectly well. It makes the semantic model view a little more crowded. And but if you need it, you need it, and it shows it very clearly. All right, I'm gonna minimize this screen here. Oh, I don't want to stop sharing. Hang on. I want to escape and go to this. All right, so I have just a model with a whole lot of tables here. It really doesn't matter what the content is for the purpose of this demonstration. So I have a clean layout, and I'm just going to do an auto layout and give this spaghetti that we're used to seeing with Power BI. Now, one of the first things I want to do is I mentioned this option that exists. So when you open the properties pane in the model view, by the way, to get to the model view, it is this third icon on the left. It gets you to the model view, gets you to this, and you'll want to open up the panes on the left side. There is a properties pane, and when you click anywhere on the blank, I don't want to call it canvas, but this view, you click anywhere that's not a table or a line, you're going to get the properties for this view. And I like to make sure these bottom 2 are turned on. Show related fields when the card is collapsed, and pin related fields to the top of the card. So these 2 are going to make it much easier for you to see the fields that matter, or the columns that matter on your table. And the other columns either fall to the bottom, where you can see them if you need them, or when you collapse your card, they disappear entirely so that you only see the ones that you're concerned with in the model view. This doesn't hide them in the other views like the data view, but it hides them enough in the model view to make this helps you recover a little bit of screen real estate and makes it a little easier to find things that are important. So from here, I am just going to zoom in to this model, And what I like to do, and I'm going to, assuming that you don't know anything about this model, you probably don't know which one's a fact and which one's a dimension. You may be able to gather some context from the names of the tables. If you can, great. Move those tables to where you think they need to go. Again, facts on top, or sorry, dimensions on top, facts on the left. If you can't decipher, or if you can't use the semantics of the naming to figure out whether it's a fact or dimension, one thing that I like to do is just look at the relationships coming off that table. So for this system table, for instance, everything coming out of it is a 1. Without knowing any better, I'm just going to shove that to the top and have it start there. And then I have this table, NCR. There's a 1 and there's a bunch of stars, manys. Again, I don't know why. That to me is a flag that something is not what I'm expecting. So I'm just going to move, but because most of the relationships, it's on the many side, I'm going to move this to the left for now and assume it's a fact table. I could be wrong, but again, the point of this is not to be right on the first try. The point of this is to very quickly identify where something unexpected is being seen. I'm going to do that. This table, I conveniently named it a bridge table, so we know what it is. But if you inherit a table, or if you inherit a model, you may not have clean naming like this. So if that's the case, I see 2 stars on it. Yeah, let's move it to the fact side, and we'll see what happens. And right away, I can see I got 2 fact tables that are joined together. That's going to be a potential issue, right? Either this is in the wrong place, or some of the cardinality needs to change, or there's another issue, right? Whatever it is, we'll troubleshoot it later. First step, though, is just get all these to a place that makes sense. And by the way, you can see when I start moving things, it's really easy for things to start overlapping. And this is where it's really helpful. Once you have these options switched on, to just start collapsing the tables. And things are just going to take a lot less space and let you see more clearly. Especially with dimension tables, you should get a lot more real estate back from doing that. Okay, so I'm looking at this personnel.
Isn't there a right-click function or something to say collapse all?
Maybe there is.
Yeah, right there.
I know there isn't.
See at the bottom?
Collapse all. Yeah, there you go. Right-click, collapse all. Okay, so we got, thank you for that, Kevin. So we got this personnel table here. It looks like all 1s. So I'm going to move this to the top. This RFI systems table, move it to the right, or sorry, to the left. We have this line table with all 1s. So I'm moving this to the top. This RFI table with mostly stars or many sides. I'm going to move that to the left. And I'm just going to keep doing that with every table I see. I see calendar or date table. I usually reserve the top left, the first spot on the top for the calendar, just because that relates to almost every fact table. So I like to, if I see a date or calendar table, I like to put it there. You don't have to. It just makes it a lot cleaner. And then you can see we're starting to run out of real estate already. And there's nothing that says we can't scroll down while we're doing this initial sort. So this goes here, this goes here, and I'm just going to move this over. This table looks like a lot of 1s. Instead of scrolling to the top, I'm just going to put all of these, what I suspect to be dimension tables, over here for now, and I'll move them to the right place after. And you can see as I'm dragging these tables around, Power BI is doing a lot of auto routing, and it's going to look a little messy while you're doing this, and that's okay. This one's got both 1s and stars, the CWP table. So again, this tells me this table is probably going to need a little bit of extra attention. Because it's got more 1s than stars, I'm just going to move this to the top for now, and then we'll figure out where it goes. And then CWAs, it's got a 1, so we'll move that to the top. And discipline has 1, so we'll move that to the top. Okay, now this is where I know these are all dimension tables. I'm just going to shrink this a little bit so I can very quickly move everything to the top, just like that. Okay, and we have a few disconnected tables here as well. And these are the ones that I said, oh, careful. Okay, there we go. We have a few disconnected tables, so I'm just going to shove these off to the right. just to get them out of the way for now, just so the lines can actually properly form that right angle. And I see this is a measure table. So I am just, again, personal quirk of mine, I just like to put that measure table on the very top left corner. So just like that, we've cleaned up that auto layout, which started out looking a little gnarly like this. And in a few minutes time, we've gotten it to this. Much easier to see what's going on. Now let's do a little bit of troubleshooting. I am looking for any relationships that aren't just forming this straightforward right angle. So I can see there's one here, there's one here, and there are a few of these relationships between what I thought were dimension tables over here. And this is where you can just start dragging things around and the lines will scream out to you. Once you know what these start to look like, the lines will tell you really what's going on. So for this one, I just dragged the CWP table and it became immediately obvious. Oh, that's just a snowflake, right? It's a dimension table that links to more dimension tables. So that tells me what it is. Do I want to keep it that way? Maybe, maybe not. It depends what I'm trying to do with this model, but at least now I know what it is. And same with over here, with these tables on the left. Once you start dragging these around, it might cause a little bit of a mess when you do that. And you just need to, this is where you need to play around with the spacing a little bit to give this enough space to show you what's going on. So once you do that, and this, it does take a little bit of jiggling around sometimes to make this display cleanly, but there it is. There's a clean view of that, what that bridge table would look like. And you can do the same thing for the one down below. And it's not always going to be this easy. And you know, as Aman pointed out, if you have a circular or a set of tables in a circular relationship, you may not be able to get it to a clean view like this ever, right? But that tells you that's where the issue is going to be, or that's not star schema. That's what that tells you. Whether that's right or wrong, that's going to be in your judgment as a developer, whether to keep that or change it. But at least now you know where it is. And then if you're OCD like me, you spend a little bit of time arranging everything. And this is pretty darn close to where we want it to end up, which is something that's a lot more easy to read and understand. So in the span of about 10 minutes, we went from a tangled mess to verifying whether something is star schema and which elements are not. And then, of course, we can follow the best practices that we talked about earlier. We check all the dimension tables to make sure everything's a 1, and all the fact tables to make everything's a star. We can hide things. Here, I can see that I forgot to hide a column, so I can just hide it directly from this table. That's it. That's the bus layout in action. Any questions? Any thoughts, comments? I appreciate that.
Some people are saying, yeah, good job. The standing O gifts.
Yeah. And Colin, as you're answering questions as they come in, I'm going to go ahead and share that QR code for the session feedback so that you guys can scan it and leave some feedback for Colin there.
And how are we doing for time, Kevin and Kevin? There is more content, but that was meant to be if we went through this awfully quick and we had some time left over at the end.
Yeah,
I got all
good.
night.
Are you asking for how well you did on timing?
No, I'm asking for it. If you would like me to fill up more time, I certainly can, and there is more valuable content. But if not, this is kind of part 1 of the presentation wrapped up in nicely. It's a natural breaking point.
So we have a question.
Yeah.
I'm sorry. Go ahead. I'm not going to be able to pronounce your name.
Go ahead.
The question is, like, can we save that the layout that you made, a bus layout, right? Preserve the layout, and maybe next time when you are opening or whenever you are sharing with others, will that layout will get preserved?
Yeah, great question. So with Power BI Desktop, when you save a file, the layout is preserved. So everything, I have a few layouts here that I use to create the presentation. So all of these layouts are preserved every time I open the file. Where people used to run into an issue is if they upload the Power BI file into the Power BI service and then download the file again. It used to be that you would lose the layouts, but now, as of a couple of weeks ago, I tried it, and the layout in the model view is preserved between Power BI Desktop and Fabric, and when you download the file again, it's still preserved. So I think there's been somebody realized that was an opportunity there at Microsoft, and they put in that feature so that it retains the layout even if you move the file around between the service and desktop.
I wonder if there's a layout JSON file now.
I would love it if there were.
Yeah, if there is, you might be able to
automate some of this.
that. And I think I tagged you on something.
You did, yeah.
Yeah, I don't know if you had a chance to look at it. I haven't had a chance to, but it seemed like somebody did invent something to kind of help do a layout. So.
Yeah, somebody vibe coded a thing to automate getting to the star schema, or sorry, not star, to the bus layout. I'm a little bit leery about downloading an executable file from somebody I know, from somebody I don't know off the internet, so I haven't tried it. But if anybody does, then let me know.
Good idea.
But it was a vibe code, so it might just be I mean, there's definitely a JSON somewhere in the PBIP folder. It's not publicized by Microsoft. But if the vibe coding Claude or ChatGPT can find it, good. That's great.
FabCon is coming. Maybe there'll be more conversation about it then.
Yeah, and I think the other thing too is if you do that, it's probably fairly easy to vibe code if it's very clear what's a fact and what's a dimension. And the person that did that actually mentioned specifically on their support documentation that they do rely on the naming. So they kind of they count on the user to name the tables dim calendar, dim dates, dim customers, dim products, whatever, and fact transactions, fact sales, fact reports, whatever, right? So they're counting on the model to tell what's a dimension and what's a fact. If you are inheriting a model that's where the originator didn't do that, this is where you do need to use a little bit of judgment, and the vibe coding solution might not work as well, or you may have to code it a little differently to make it work using the criteria we used, which is how many relationships is it on the one side of versus the many side of.
To your point, Collin, I think that this is where there's a great opportunity if there was some sort of metadata field to where you could, as a modeler, say, hey, I want to flag this as my dimension table without having to name it dim calendar or as a fact table.
Yeah, and I think, and Kevin, you know Fabric a lot better than I do. Within Fabric and data warehouse and SQL data warehouses, there is a way to do that, is that not? It's just in Power BI that doesn't exist.
Sorry, I was going through the chat to see if the people that wanted the certificates are still here, but unfortunately, I don't know that they are. Was the question about
just designating a table as a fact or dimension without naming it that way?
Yeah, you could use them in databases, right? Or any of the databases that support a schema. I use a schema called dim and a schema called fact. And then that way I don't have to name my actual table names that way.
Mm-hmm.
So.
Yeah, Collin, but there's nothing that cascades down.
Yeah, Power BI doesn't support that. So it would be nice if they had, but I don't know how many people, even if they did, I don't know how many people would use it.
It kind of does, kind of doesn't.
Yeah.
If you go through Tabular Editor 3, it has a way of grouping.
That's right. Yeah.
And then that grouping gets put in as an annotation in the model, and then you could use it to pull them back out.
Yeah. And the other thing, I mean, you can always click on any table and you could always enter it as a description, fact table, whatever. But that's something that you would do almost as a comment to yourself rather than as an annotation that would be read semantically by others.
Yep. Yeah, because I have a documentation generation that looks for those annotations and helps me break it up. So unfortunately, I think the people that wanted the certificates, is there anybody on that could put their email in the chat that wants one of these free vouchers for either Fabric or okay, I got the one that I was looking for. And I don't know if I think there was somebody else that maybe wanted to was thinking of a PL 300.
Looks like demo.
Them, yeah. So if you want one, put your email in there and tell me what you're looking for. Tell me if you're looking for the PL 300 or the DP 600 or 700. And again, the test has to be taken by the end of this month. And I only have 2 of each, so.
All right, so I see 2 comments, Damu and I can't pronounce the other name. If you guys can specify whether you're looking for PL 300 or the remaining DP, that'd be good.
Yeah, Charlotte, if you're still listening, which one did you want? I think it was one of the, it was for the DP,
600.
right? Okay. Okay, so Charlotte and Damu will get the 2 for Fabric, and I still got 2 more for the PL 300 if anybody's interested.
And reminder that the PL 300 is a 50% discount, but that's still 50% opportunity here.
Yep. Okay, I'm going to go ahead and turn off the recording. We can kind of start wrapping this all up. Good job. Let's see.
Yeah, and I'll ask, has everybody captured the session feedback QR code yet?